In this investigation, we looked at rewriting formulas to represent inverses. Let's review some of these ideas using examples. Consider a square whose size can vary. If x represents the length of one of the sides of the square in inches, and p represents the perimeter of the square in inches, then p equals 4x expresses p in terms of x. We can define a function f to represent this relationship. So we can say f of x is equal to 4 times x, where the output of f is representing the perimeter p. The function f has an inverse, and we know that f inverse will take as its input p and output the value of x. So if we go back to our formula expressing p in terms of x, we can actually solve for x, and we see that x equals p divided by 4. This formula expresses x in terms of p, which is exactly what f inverse is doing. So in this case, f inverse of p will be equal to p divided by 4. Again, this is because both f inverse of p and x are representing the same thing. We also saw that we can use similar reasoning even if our function is defined using parameters. Recall that a parameter is a letter that represents a value that is fixed within a context but can change if we change our context. For example, suppose f of x is equal to m times x, where f of x is equal to y. In this case, x is our input or independent variable, so we'll just say independent variable. Y is our dependent variable, and in this case, m is a parameter. Now we can think about m achieving any values, but let's look at a couple specific examples. If m is equal to 2, then f of x will be equal to 2 times x. Similarly, if m is equal to 2.5, we just change our context a little, then f of x will be equal to 2.5 times x. Regardless of the value of m, y is always equal to m times x. So we know that y is always equal to m times x, no matter what the value of m is. So we can solve this formula for x, and we see that x is equal to y divided by m. And therefore, our inverse function, f inverse, will take an input of y, and the rule for this is y divided by m, because f inverse of y gives us the value of x. Now, since we can change the value of m if we want to change our context a little bit, if we tweak the value of m in our definition for our function f, then the definition of f inverse will also change a little bit so that f inverse will always be the inverse of f. Now, we also looked at a slightly confusing convention. Often, mathematicians like to stick with using x as the independent or input variable. So instead of writing f inverse of y is equal to y divided by m, it is common to use x as the input variable to f inverse. So in this case, we're using x as our variable. So f inverse of x would be equal to x divided by m. Now this is a little confusing, but given any input value, f inverse will produce the same output value whether we write this using y's or we use the slightly more confusing version which uses x's. So be aware that you might see inverses written where it looks like we switched x and y once we wrote our inverse. This is just based off the convention that it's common to use x as our input variable.